Greetings from the past. Alright, so we're working on representing motion now, and we've been working on this one big equation. That's not it. It is v equals delta x over delta t. So this is our displacement over our time interval. And we're going to continue that on here. We're filling in this chart, changing position versus timetable to velocity versus timetable. So position versus time. Remember, we're looking for the midpoint here. So we have 42 minus 18 because this is the same thing as x final minus x initial. And all of that is going to be over t final. I think I just figured out the I. T. Haha. Right. So there we go. So we have our final time, 42 minus the initial time is going to give us 24. Is our delta x. So that equals 24 on top. And then for the delta t, it's going to be 8 minus 6, 2. So our velocity becomes 12, and the time is the halfway point. Because remember, this is kind of the downside to doing it this way, is we don't really know what's happening for that full second, and there's an infinite amount of points between those 2 seconds, so it's not really accurate. But continuing on, we have 82 minus 42 is going to give us 20, and I'm going to fill this chart in pretty quick here. We went through it once. It's the same thing over and over again. Make sure you know how to do it. And you can check yourself. Pause right here. Make sure you're doing it correctly. Make sure I'm doing it correctly. If you're seeing something that I just completely messed up, please let me know. But I'm fairly confident in this. All right, moving on. We're changing velocity versus timetable into a velocity. No, that's a typo. Into a position versus timetable. Assume the object begins at x naught equals 100. Okay, so that's going to come into play. So our initial position is 100. All right, let's see this. We are in between these 2 points. So between 0 and 10, we started out at t naught, the initial time. Our velocity is 0. And then all of a sudden we're at 10. Somehow we have increased there. So if we say like the midway point between these two, we had to have been at 5 meters per second. Right? And it took 5 seconds. So our average velocity for these first 10 seconds was 5 meters per second for 5 seconds. So we're going to take the same equation from above and just rearrange it to get x equals, displacement equals v times our time interval. So our average velocity was 5 and our time interval was 5. So that means that's going to give us 25, right? Yes, our displacement is 25, but our position is not. This is asking for position. Notice there's no delta there. So we're only looking for position. So we're going to take 25 plus 100, and we're going to get 125. And it took 5 seconds. And we can see the pattern here. Each time interval is 5 more seconds. So the time is not changing. Same time, same motion, same situation. So we're just filling it in with a little bit more detail. I'm going to do one more of these before sending you off on your own. So again, the average velocity between 0 and the average velocity between 10 and 20 is 15. Right? And then the time interval again is 5. 5 times 15. 15 times 5 is going to give us 5 to 75. So now we're going to take that 75, because remember that is our displacement, it's not our position. Take that 75 and add it to the position that we were at to get us at the 200 meter mark or 200 centimeter mark. Okay. So we're going to keep doing that, and I'll put your answers here so you can check yourself, lest you wreck yourself. 725. There you go.